Hey, welcome back to Squid. In this video, we're going to be doing a review of coordinate geometry, including 10 questions. So make sure for each question you pause and you attempt it yourself and then play and see what the answer is. Okay, let's get started. Review of coordinate geometry. Here's question 1. It says, state the coordinates of points A, B, C, D, and E on this Cartesian grid. So I'm just going to zoom in here. I'm going to show you for the first one, I'm going to try to solve A. So here, remember how we solve this if we go along the X and then the Y. So every coordinate geometry question, every coordinate has two parts to it, an X and a Y. Okay, the X is the left and right and the Y is up and down. So if I'm going to take the coordinates of point A here, I'm going to go 2 across, that's up to here, and 1, 2, 3 up. So that's 2, 3. What I'd like you to do is solve the rest of them. So for part B, we have -2, 2. For point C, we have the coordinates 3, 0, because it hasn't gone up or down the y-axis. It's at 0. Okay, let's see the next one. We've got D, which is -3, -4, and then E, which is at 2, -4. So well done if you got those questions right. Let's move on to question 2. So for question 2, it says, on a set of axes, illustrate all the points which have equal x and y coordinates. So here's your grid. Draw all the points that have equal x and y coordinates. So if I start by marking off the axes, I can say that's 2, 4. I'll go up here, 2, 4. So for all the points that the x and the y are equal, so if I have an x coordinate of 2 and a y coordinate of 2, a 2, 2, that would be that point there. If I had an x of 4 and a y of 4, that would be that point there, 4, 4. And remember, it says all the points where x and y are equal. So I could go into the negatives as well, and I can have a -6 and -6. So all the coordinates for the x and the y that are equal. And now we can attempt to draw a straight line through the points. Okay, well done. Let's move on to question 3. Question 3 says, for the equation y is equal to 4 minus 3x, construct a table of values with x is equal to -3 all the way up to 3. Draw the graph of the straight line and then state the gradient and the y-intercept of the line. So pause the video here and have a go yourself, and then I'll show you the result. Okay, so to start off, we need to do a table of values. So I'm going to say that that's my x and my y. Now I can find out all the values of y by substituting each one of these values into the equation. We're going to do y is equal to 4 minus 3 times -3. 3 times -3 is 9. We're going to have 4 plus 9, so y therefore is equal to 13. So we can write here 13. The next one, y is equal to 4 minus 3 times -2. -2 times -3 is going to be +6. And then 4 plus 6 is going to give us the value of 10. So y is equal to 10. Okay, let's just do one more. Let's move this out of the way. So we've got y is equal to 4 minus 3 times -1. That's going to give us 3 plus 4 is equal to y. Y therefore is equal to 7. So y is equal to 7. And what you can notice here is that we have a pattern. It's -3, -3, and I reckon it's going to continue to be -3, -3, and so on. So 7 minus 3 gives me 4, 4 minus 3 gives me 1, 1 minus 3 gives me -2, and then -2 minus 3 gives me -5. Okay, so they're the points that we're going to use to draw this graph. Let's label the axes. That's my x and that's my y. Now in my particular graph, I don't have a massive range, so I'm just going to go with these values here. So I've got 0 and 4, so 0, 4. I've got 1, 1, so 1 and 1. Then I have 2 minus 2, so 2 minus 2. And then 3 minus 5, so 3 minus 5. Now I can see that those points make a straight line. So I'm going to go ahead and draw my straight line in here. Now I don't have to plot all of these points because I just don't have the space on the graph. So part C, state the gradient and the y-intercept of the line. The y-intercept simply is the part that cuts through the y-axis. So that is the coordinate 0, 4. That's your y-intercept. The gradient, we can just use the gradient formula. The gradient formula, if I remind you, is y2 minus y1 divided by x2 minus x1. Now I can substitute any 2 points from the table of values in order to find out the gradient. So we'll have these points and these points. So we'll have 3, -5, and we'll have 2, -2. Now very quickly, I'll just call that my x2 and my y2, and my x1 and my y1. So let's substitute these in. So my gradient is -3. So 4 is the y-intercept and -3 is your gradient. Okay, moving on to question 4. So question 4, an accountant charges a £70 consultation fee and then £120 per hour thereafter. Part A, identify the independent and dependent variables. Make a table of values for the cost C for an appointment with the accountant for T hours, where T is equal to 0, 1, 2, 3, and 4. Draw a graph of C against T. Part E, is it sensible to join the points graphed with a straight line? Explain your answer. And then part F, for every increase in T of 1 hour, what's the increase in C? So see if you can answer these questions and then I'll show you the solutions. So part A, identify the independent and dependent variables. If we were to quickly just draw a quick little sketch, okay, of time against the charge. Now think about this, time will be along the bottom and the cost will be along the y-axis. Now, the cost depends on the amount of time that we spend in the accountant's office. Okay, so if we make an appointment, we're going to start off the appointment with a consultation fee of $70 or £70, and then it's going to go up per hour. So if that's 1 hour, 2 hours, 3 hours, it's going to go up per hour depending on how long we stay in the office. So the cost is dependent on the time, which is independent. Cost is dependent, time is independent. Okay, part B says make a table of values with C against T. So what we can do here is we can do a quick table of values here. We'll do time and cost. We know time is going to be 0, 1, 2, 3, and 4. And we want to find out how much is going to cost. So if we book with the accountant for consultation, the fee to book is £70. And then for each additional hour, he's going to charge us £120. So 70 plus 120 gives us 190. And then we're going to add an additional 120 here. So we get 310. And then we're going to add an additional 120 here. So we get 430. And then we're going to add a final £120. And that's going to give us £550. So that's the table of values. Let's go back to C. It says draw the graph C against T. So let's draw a graph here. Okay, so we have our time at the bottom. And we have our cost along the side. This is in pounds, and this is going to be in hours. What we can do here is we can have a broken axis because in actual fact, our fees don't start until 70. It starts here at £70 and it goes up every £120. So maybe if we start at 50 and then we go up in 50s, 500 and 550. Okay, so we need to draw this now. So let's label our points. So for 0, we've got about 70 somewhere. And then for 1 hour, we're going to go up to 190. So that's nearly 200. And then for 2 hours, we're going up to 310. And then for 3 hours, 430. And then for 4 hours, we've got 550. So we can stop there. Part D says, is the relationship between C and T linear? So let's have a look. Is that a straight line? Does that represent a straight line? Well, it does actually, yeah, it represents a straight line. So therefore, the relationship is linear. And we also know that because we can confirm that by looking at the difference each time we go up by 1 hour. Okay, every additional hour has a rate of change of $120, £120, sorry. Is it sensible to join the points graphed with a straight line? Explain your answer. So let's think about this. Can we draw a straight line joining all the points for this linear relationship? Well, if we stayed in the accountant's office for an hour and 15 minutes, is he going to charge us for those 15 minutes? If he charges an hourly rate of £120, is he going to now start saying, okay, well, it's a quarter of an hour, I'm going to charge you a quarter of £120? If that was the case, then we could sensibly draw a line through the points. But since that's not mentioned and he charges by the hour, I think we leave this without drawing a line, without drawing a straight line through the points. Okay? So that's okay. Now part F says for every increase in T of 1 hour, what's the increase in C? What's the increase in the charge? We already know the answer to this. For every increase of an hour, he charges an extra £120. Okay, that's part question 4 done. Question 5 says state the gradient of each line. Use the grid in order to find the rise and the run. Okay, so for line A, we have a rise of 2. That's a rise of 2, and we have a run of 1, 2, 3, 4, 5. That's a run of 5. So we have rise over run which in this case is 2/5. So we have a gradient of 2/5. Now, from left to right, this line is increasing, so we have a positive gradient. Okay, so it's going to be positive 2/5. Let's look at line B. We have 1, 2, 3, 4. Let's just say we're going down to 5. So that's -5. We've gone down, and then we've got 1, 2, 3, 4 across. Okay, so we have -5/4. That's my rise over run. And because from left to right, this line is actually going down, that's why we have a negative gradient. We have a negative gradient. So we have -5/4. And it's perfectly fine for you to leave it like that, -5/4. You don't have to convert it to a mixed number, -1¼ Okay, if you really wanted to, you could, but you could leave it as -5/4. Okay, question 6, it says, on the same set of axes, draw graphs of the lines with equations x is equal to -2.5 and y is equal to -4. So have a go, and then I'll give you the answer to what I got. So first thing first, we want to draw a set of axes. Right, so now we're going to plot the first one. X equals -2.5. -2 is there. -3 would be there, so -2.5 would be at that point there. So let's draw that. So a straight line that is always -2.5. So I can draw a straight line going through these points. Okay, and then it says y is equal to -4. So y is -4 would be this line here. So let's just draw a line through there. Okay, actually I'm going to label these as well. So y is equal to -4, and I'll label this one x is equal to -2.5. That's what you should get. So question 7, state the gradient and y-intercept of the line with equations a, b, and c. Attempt these questions for yourself, and then I'll show you what the answer is. So first thing first, remember that every straight line has the equation y equals mx plus c, and we know that m is the gradient and c is the y-intercept. For part A, we have the gradient of 4 and a y-intercept of -3. So let's just write this down. We have a gradient which is equal to 4, and we have a y-intercept, okay, which is equal to -3. So for part B is a tricky one. You have the gradient here, which is -1, and we have the y-intercept of 2. So we have a gradient of -1, and we have the y-intercept, which is equal to 2. So let's have a look at part C. We have all of this divided by 2. Now we can separate that, and we can say 3x divided by 2 and -½ divided by 2. So let's write this down. We've got y is equal to 3x over 2 and -1/2. Now the gradient over here, the gradient is equal to 3/2, and my y-intercept is equal to -½ So question 8 says find the x and y-intercepts of each of the following lines, and hence find the gradient of each line. So attempt this again for yourself, and then I'll show you the solution. So for part A, we have -3, 0, and we have 0, 4. That's the x-intercept, and this is my y-intercept. Now since we have those 2 points, we can find out the gradient. We're going to do y2 minus y1 over x2 minus x1. Make sure you substitute them in the right order. So we're going to have 0 minus 4 divided by -3 minus 0. So we have -4 over -3. And that gives us a gradient of 4/3, or 1⅓. Okay, so we have a gradient of 1⅓. Part B, we have a y-intercept of 0, -2, and an x-intercept of 3, 0. So -2, and then we've got 3 minus 0. So that's 2/3, 2/3. So we have a gradient of 2/3. Finally, let's do part C. I have my y-intercept as 0, 4, and an x-intercept of 3, 0. And actually I can write that as -1⅓. So we have a gradient here of -1⅓. And we know that because from left to right, this line is going down. Okay, so we're nearly there. Question 9, for each of the following lines, state the gradient and y-intercept and draw the graph of the line. Okay, so for part A, we have a gradient of 2. Okay, that's my gradient of 2, and my y-intercept of -3. In fact, I can quickly graph this as well. that's my y, that's my x. Let's try to graph this first point. So we have minus 3. E squared is going to be 1 unit, so that's minus 3, and then I have a gradient of 2. Now look at this, a gradient of 2 means 2 up and 1 across, okay? So that means I'm going to go 2 up and 1 across, so that's going to be that point there. So if I put that point there, and then I can draw my straight line through these points. So that is A. I'm going to label that graph A. Graph B, have a look at this very quickly. I have a gradient of a third and a y-intercept of 1. So I can start off by doing the y-intercept, that's 1. And then I need to go, it's a third, so it's going to be 1 up and 3 across. This is what it is, 1 up and 3 across. So 1 up and then 1, 2, 3 across, it marks that point there. So I could do a straight line that passes through those points, and that's going to be line B. Now for line C, I have a gradient of -3. My gradient is -3, and my y-intercept is 8. This is my y-intercept. So 0,8, that's the y-intercept. Let's see, do I have 8? 1, 2, 3, 4, 5, 6, 7, 8 is going to be up here. And then -3, a gradient of -3 over 1 means I'm going to go 3 down and 1 to the right. So 1, 2, 3 down, 1 to the right. That's there. And then I can draw my straight line passing through those points. That's near enough. So last question, question 10, it says find the equation of the lines. Again, pause the video and attempt for yourself, and then I'll show you the worked solution. So for part A, we have a y-intercept here. So that's my y-intercept. My y-intercept is -3. So remember, every line has an equation y is equal to mx plus c. I know that I have a c of -3, and I can substitute my x and my y is equal to 2. So I can substitute those values into the equation to find out what m is. So let's do this. We've got 5m minus 3 is equal to 2. If I plus 3 on both sides, I end up getting 5 is equal to 5m. If I divide that by 5, divide that by 5, m is equal to 1. So I've got my gradient is equal to 1, and I've got my y-intercept is -3. So I can have y is equal to x minus 3. And look, I don't need to write here 1 because I know it's going to be 1x minus 3. Let's look at the next question, part B. We have a y-intercept of 1, and then we have this point here. That's my x and that's my y. Remember, every straight line is y equals mx plus c. Let's substitute the values that we do know. We've got -2 is equal to, I don't know what m is. I know my x is 4 and my c is +1. So 4m plus 1 is equal to -2. If I minus 1 here, -3 is equal to 4m. Divide by 4, divide by 4. I have a gradient, m is equal to -3/4. So my equation is going to be y is equal to -3/4 of x plus 1. I could highlight that. So well done. That's the end of this task, end of this video. I hope you've done well. Go back and check your answers. And as always, thank you for watching. And if you haven't, then consider subscribing, and I'll see you in the next one.